Is time travel possible? Hello and welcome to Z, and today, we try to see if time travel is possible. Follow me by clicking the notification bell. Time travel is a popular topic for both scientists and science fiction writers. Imagine being able to travel back in time and pay a visit to Marilyn Monroe or Galileo. The concept of traveling between 2 points in time is appealing. We've all seen movies that feature time travel, and everybody has their own theories about it. But the truth is a little different. Time travel is not universally accepted by scientists, and the method itself is complicated. But first and foremost, we must define time. We are all familiar with the three spatial dimensions that comprise space. All physical objects have three dimensions. They are as follows: length, width, and height. There is also a fourth dimension, which is time. To travel in the above three dimensions, we must do something, such as driving in a straight line moves us along one dimension, turning moves us along the second dimension, and climbing a cliff moves us along the third dimension. However, time travel occurs all the time. Everything has a length in both time and space. We are always moving through time, whether we are at rest or in motion in space, and this relationship gives rise to the concepts of spacetime and time dilation. We'll get back to that later. The most complicated concept of time travel is time travel to the past. Many scientists say that it is not conceivable since it involves contradictions. The most general concept is time travel via wormholes. The concept of wormholes is permitted under Einstein's general theory of relativity. Wormholes are a difficult idea to grasp, but bear with us. We are all aware that none of the three dimensions are flawless. If you look attentively, you will notice that everything has holes and wrinkles in it. It is a fundamental physical principle that also relates to science. Take, for example, a pool table, which is full of gaps and holes when examined at the molecular level. Nothing is really perfect. This is easy to demonstrate in all three dimensions, but it also exists in time. There are tiny cracks and holes in time, and we come to a location called quantum foam when we go down to scales smaller than even atoms. Wormholes can be found here. Tiny tunnels or shortcuts through space and time that form and disappear all the time. They can connect two distinct locations at different periods. Unfortunately, these time tunnels are billionths of a billionth of a centimeter in diameter, too small for a human to traverse through. Some experts believe it is conceivable to catch one and increase it trillions of times using a lot of energy to make it large enough for a human to pass through. You may have seen this notion in Avengers: Endgame. Wormholes, on the other hand, are a difficult idea to grasp. However, many people believe that it is not conceivable in real life. Let's talk about why. The paradoxes that might hinder time travel are one of the key explanations. Consider a simplified version of it. Let's say you had the ability to travel back in time and meet your grandfather, but you don't like him and shoot him. I'm just asking everyone to take a hypothetical circumstance and not upset anyone. So, if you had shot him, he would never have met your grandmother, and your father would never have been born. And if your father had not been born, you would not have been born, but you are still alive and able to meet your grandfather. So the cycle continues. This does not make any sense. This type of time machine would be in violation of the universe's fundamental laws. The law of causality states that causes occur before effects and never the other way around. And I believe that nothing can make them impossible, since that would destabilize the entire cosmos. As a result, it is assumed that something always prevents the dilemma. Something will always save us from going back in time and murdering our grandfather. I hope you all understood what we were trying to communicate. Wormholes may not be achievable in the end. Though small wormholes may exist and be inflatable, they will not endure long enough for a time machine. As a result, time travel to the past is not feasible, otherwise, paradoxes would arise. It's disappointing. However, this does not rule out the possibility of time travel. We believe that future time travel is always feasible. The concept of time travel to the future is based on Einstein's theory of relativity. This is when time dilation comes into play. We've already talked about how we work against the clock. Time and space are interchangeable, or two sides of the same coin. When we move through space, some of our motion is diverted into motion through time, and vice versa, in the same way that a car traveling northwest diverts some of its northward velocity towards west. Space and time are linked in the same way that the x and y axes are. The only difference is that we cannot move only through space, we also move through time. We always move through time, even when we are at rest, but when we move through space, some of our motion through time is diverted towards space, and thus time is less than it should be, or time is dilated. One of the most exciting notions in physics is the concept of time dilation. Einstein's work leads to the strange conclusion that time moves relative to the observer. Time dilation occurs when an object is in motion, which means that time flows more slowly when one is moving than when one is at rest. As a result, a person who is active ages more slowly than one who is at rest. We can only assert that moving clocks run slower than stationary clocks. How? As I previously stated, when we move through space, some of our motion is redirected from time to space, and time goes slowly. Time would move regularly for a moving individual, but it would appear to move slowly when watched from a different inertial frame that is at rest. This is especially noticeable at speeds nearing the speed of light. Consider a 15-year-old traveling at 99.5% the speed of light for 5 years from his point of view. According to NASA, he will be only 20 years old when he returns to Earth. His Earth twin, on the other hand, would be 65 years old. The twin paradox is another name for this. As a result, when astronaut Scott Kelly spent nearly a year aboard the International Space Station in 2015 to 2016, his twin brother Mark Kelly aged a little faster. To some extent, I can argue that the faster you travel, the slower you age and hence the leaner you are. It is not visible in everyday life because we travel at far slower speeds than the speed of light. The closer an object's speed approaches the speed of light, the more distorted lengths and time intervals tend to become. The greatest practical application of this dilation is obvious. The navigation system. If you have a global positioning system, GPS, receiver in your automobile, it will seek signals from at least 3 satellites in order to synchronize your position. The GPS sends out timed radio signals that the receiver picks up on, triangulating its position depending on signal travel time. The problem is that the atomic clocks on the GPS are moving and thus move slower and faster due to weaker gravity, because gravity dilates time, as we will see in general relativity, but overall they move faster than clocks on Earth, causing timing issues. Because the GPS satellites are above the Earth and experience less gravity, the clocks in our space are ticking quicker. So, even though GPS satellites are constantly moving and endure a 7 microsecond slowing every day as a result of their movement, the results of the lighter gravity cause clocks to tick 45 microseconds faster than ground-based clocks on Earth. So, when we add the two measurements together, the GPS satellite clock ticks faster than ground-based clocks on Earth by around 38 microseconds every day. As a result, engineers must make GPS clocks tick slower. Since a result, we can believe that traveling near the speed of light might theoretically allow time travel into the future, since time slows down for the speeding object in order to prevent the cosmic speed restriction of the speed of light. A corollary of all of this is that if humans could exceed the speed of light, we could travel back in time, as seen in the TV show The Flash, while some scientists believe that some as yet undiscovered law of physics may intervene to prevent such paradoxes. Actually, special relativity does not preclude the existence of particles that can travel faster than the speed of light, and there is a hypothetical subatomic particle known as tachyon that could spend its entire life traveling faster than the speed of light, but it is still hypothetical. Because of gravity, time travel into the future is also conceivable. Let us return to the two twins. If one of them is in a spaceship that orbits a black hole, the gravity of the black hole causes time to slow down. Cooper and his friends, as depicted in the film Interstellar, landed on a big watery planet with gravity 130% stronger than Earth and located near a supermassive black hole with a mass 1,000,000 times greater than the Sun, which it orbits at 55% the speed of light. That implies Cooper's friends on the spaceship are experiencing time faster. An hour on the planet is equivalent to 7 years on the spaceship. That is simply incredible. Though the concept of time travel to the future is not widely entertained, it is a very possible scenario. We might see that in the future. So, what are your thoughts on the subject of time travel? If you have any comments or questions, please leave them in the section below, and remember to like, subscribe, and share our video. Thank you very much.